Continuing our talk on water resources, 11.2 has us exploring how much water we use. So we're going to be discussing this idea of virtual water and the exportation of water. We're going to talk about what products tend to use more water than others, and we're also going to discuss domestic water supplies and how those protect health. When we discuss how much water we're using, there's a lot of complex factors at play. Water is more than any other environmental factor will dictate where human populations tend to be. So the availability of water determines the location as well as the activities of human beings here on the earth. If you take, for example, a place like Iceland, they have a very small population, but they have very abundant rainfall. Whereas other countries such as Egypt have very large populations, but limited access to water supply. So therefore, in Egypt, almost all of the population lives adjacent to the Nile River so that they can have a higher water availability because that's where the water is, so that's where the population lives. Water supplies are resources that are replenished regularly. We talked a lot in the last section about the difference between groundwater supplies and aquifers, which recharge very slowly, versus surface water and shallow groundwater that can replenish very quickly or recharge quickly. So kind of depending on where you're getting your water resources from, that can dictate whether those are replenished regularly or not. Water is a renewable resource, but renewal does take time. The rate that we use water makes it essential that we protect and conserve local water supplies. So we saw last section how we are taking more water out or withdrawing more water than water is being replenished. So the amount of water we do use as humans depends on a lot of different factors. First and foremost, it depends on how much agriculture a region has. It also depends on how much meat that particular population consumes, because that's going to take a large withdrawal of water, how dry the climate is, and how much water is available to use from the get-go. In the US, we know that we are overusing water compared to, say, a developing country. In the US, we consume about 1,600 square meters of water per person per year. Most of this, though, is resulting from high agricultural water use, warm climate, also a rich diet. And when we say rich diet, we are talking about beef consumption. Just getting beef from birth to the dinner table is going to take a lot of water, and we're going to talk about that later on. Whereas if you're to look at a developing country, they tend to use much less water than we do. They're using about 50 square meters per person per year. So our domestic water use is incredibly high compared to developing countries. Something else to keep in mind is that renewable water is most plentiful in the tropics, but they also have very heavy rainfall and very large land masses that contribute to that as well. The idea of virtual water is kind of a tricky topic. So we're used to talking, at least previously when we talked about the hydrologic cycle, water being evaporated and then being moved to a new location and being precipitated or put in another location. When we talk about virtual water, we're not talking about just liquid water or solid water moving from one location to another. Now we're talking about water that is being used by an organism, being tied up in some sort of product, and then being exported or moved around. So this also contributes to the movement of water. Water withdrawal is the total amount of water taken from a water body. So when we talk about virtual water, it's really hard. We cannot forget that we are withdrawing water from one location and sending it to another. Let's use the example that your book uses regarding California and their production of alfalfa hay. So 15% of all water used is consumed in California for producing alfalfa. And alfalfa is used to feed dairy cows for the most part, and then to some lesser extent it also feeds beef cattle. From these cows we get products like milk, cheese. We also get beef or meat. And these products are then exported across the U.S. They're also exported overseas to a lesser extent. So what we're essentially doing by growing alfalfa is we're tying up the water used to grow that alfalfa, and we're tying it also up into those beef products, the milk, the cheese, the meat, and then we're sending it to another location. So water is still being withdrawn from California and moved elsewhere. California also does export alfalfa hay directly to China, Japan, and elsewhere. These would be considered, because the water is tied up in the alfalfa, these are virtual water exports. So when we don't eat locally, we are moving water virtually all over the U.S. So we're redistributing that water. It makes a good case for being a locavore. To give you just a rough idea of how much water we're talking about, by some estimates, your water content that is exported in alfalfa amounts to 380 million cubic meters. And I know we don't do well with cubic meters. That is 100 billion with a B, gallons of water per year. This would be enough water to supply 1 million families with drinking water for a year. So these are massive amounts of water that are being exported virtually. Raising just a kilogram of grain-fed beef can take more than 15,000 liters of water, whereas if we were to raise a goat instead, that's going to require about 90% less water, and this is just due to the varied diet that the goat eats, and also goats are able to more efficiently metabolize their food, so they take less water for that. The reason cattle take so much water is because cattle are fed corn. The corn has to be grown. This is another agricultural use of water. And to grow corn, we need water-intensive irrigation systems. So it takes a lot of water. Not to put a downer on our cheeseburgers, but the average cheeseburger is going to take about 2,400 liters or 630 gallons of water to produce. So we're talking about massive amounts of water for our beef-rich diet. But moving away from beef, if we were to talk about rice cultivation instead, these usually occur in wet paddies. It's going to take about 3 times as much water as raising potatoes or wheat. So if you're growing rice in a rainy region, this is not an issue, but if you're growing it somewhere where it's not rainy, it's going to require a ton of water. So changing the way we eat and changing the crops that we grow, or changing, not eating as much beef, is going to have a very big impact on our water consumption. Love this graphic because it gives us a visual about how much water is used in food production. So on the last slide, we talked a lot about beef and beef products versus goats versus potatoes and corn and rice. But this gives us a very visual representation. So what you're looking at here is the amount of water required to produce 1 kilogram of food from each of those sources. So that's your equalizing factor for those. Again, we said beef takes a lot. We talked about it needing 630 gallons just for a single hamburger, which is quite amazing if you think about all the hamburgers, at least I have eaten over my lifetime, how many gallons of water have gone into that. We also compared that to the goat, which we said the goat has a much more varied diet and also metabolizes its food a lot more efficiently and doesn't need as much water. That's significant. I'm not sure there's a market for goat products, but we're starting to see more goat milk and goat cheese being produced. Rice, as we mentioned earlier, takes about 4,000, a little under 4,000 gallons of water for 1 kilogram of rice, versus potatoes and wheat take about 1/3 of that. And again, a lot of this is going to depend on where is this agriculture going on. What is the climate like in that particular region? Is rice being grown in a rainy region, or is it being grown in a more arid and dry region? Are you going to need more irrigation there, or are you going to be supplied with more water from precipitation? So there's a lot of different factors that go into play. We're going to have to address this. Chocolate is on the bottom and uses the most water. Chocolate. So this is one of those weird situations, and it happens a lot, where your greatest use of water is not in growing the cocoa bean, but it's actually, there's more water used in preparing the cocoa bean to become chocolate. So as you know, chocolate is highly processed. Well, that's going to take a ton of water to go through the preparation of chocolate, not necessarily in the growing. So that's another way that we see virtual water exportation, is in the process of getting these products, these food products, ready for market. Well, agriculture is the single biggest use of water withdrawal. Industrial and domestic uses also are going to use a decent portion of the water supply. So some European countries use about 70% of water for industry, and less industrialized countries use only 5%. A lot of this water is used, say, by power plants as cooling water. This is the largest industrial use, is cooling water for power plants. Typically, this accounts for about 50 to 75% of industrial withdrawal. The hope is that we can take this cooling water and recycle it. That doesn't always happen, but sometimes we're able to recycle that cooling water and use it again, or use it for something else. We are seeing a rapidly growing demand for water in biofuel production. So biofuel is taking corn and making ethanol, which would be fuel for our cars. It does demand extreme amounts of water, though. It takes 4 to 7 liters of water to produce 1 liter of ethanol. So that's quite a discrepancy between how much water it takes to use and how much product you get out of that, which has kind of been the trend for this entire section. Way more water in than what you get out. And this all is going to depend on how much irrigation your corn stalk is going to require. So am I going to have to water my corn plants a lot because I'm in an arid climate in order to get the corn to grow, in order to take the corn and use it to produce the biofuel? Water shortages, interestingly, may be what limits our switch to biofuels. And this is not up on your notes right now, but it's worth mentioning. We're going to talk a lot more in the next chapter about this, but another dominant industrial use of water is hydraulic fracturing or fracking. This is a way that we get natural gas and oil out of the earth. What we do is we take high pressure water and we pump it into oil and gas wells, and the hope is that this water under high pressure can break apart geologic formations and release hydrocarbons that are locked in the rocks. Fracking is going to use about 4 to 6 million gallons of water. That's you don't need the liters, we work in gallons. And unfortunately, sometimes these wells have to be fracked more than once in order to release additional gas. So when this water goes into the earth, it goes in clean, but it comes out contaminated. It is so contaminated it can't be reused, and it's going to have to go through treatment. Contaminants that we see come out of hydraulic fracking are going to include carcinogenic hydrocarbons, so cancer-causing hydrocarbons, detergents that aid in the fracking process, as well as salts. Sometimes we get radioactive particles, just depending on what geologic formations we're breaking up. But again, this is just a preview for the next chapter when we talk more in depth about that. So we talked about agricultural water use as being the highest usage of water, followed by industrial use. Domestic water only accounts for about 6% of world water use. And when we say domestic water use, we're talking about water that is being used for drinking, cooking, washing, anything having to do with maintaining a household. So only about 6% of that is being used in a domestic sense. These amounts do vary with wealth. The more wealthy you are, the more water you're going to use. The United Nations reports that people in developed countries consume on average about 10 times more water than those in less developed or developing countries. That is further compounded by the fact that poorer countries often can't afford the infrastructure to obtain and deliver clean water to its citizens. If you cannot pipe safe public water to neighborhoods, your residents are going to have to buy high-priced water that is delivered by truck. Unfortunately, this tends to keep families in poverty. You don't have a choice about water. You have to have clean, safe drinking water. But again, they have no choice as to how they get their water. Providing cleaner water to poor populations is one of the primary aims of international development organizations. Clean drinking water and basic sanitization go hand in hand. These are necessary to prevent communicable diseases and to maintain a healthy lifestyle. Communicable diseases that cause diarrhea is one of the symptoms, are going to be one of the most dangerous. Having diarrhea can cause a quick death, especially for children. The United Nations estimates that at least 1 billion people lack access to safe drinking water, and 2.5 billion people do not have adequate sanitization. So as populations grow and more people are moving into the cities, we are seeing water shortages, and they're becoming worse because we have agriculture and industry also competing with people for those domestic water supplies as well. If you tend to live outside of the city, you are probably going to have less access to good water than people who live in the city. Water-related diseases that cause diarrhea are very common in places that don't have access to good sanitization or sanitation. Every year, about 1.6 million people, 90% of that 1.6 billion people are children under the age of 5, are going to die from diarrhea. That is more children than die from malaria, measles, and HIV/AIDS combined. So this is definitely an issue that needs to be on the forefront of our attention, is providing clean water for domestic use and better sanitation for residents around the world.